Okay, here we go. I'll do merge sort.
Okay.
Um, and I'll start with inputs, outputs. As I understand it, in merge sort, our input is going to be an unsorted array of numbers. Output should be a sorted array. I guess it's as simple as that. And then the constraint would be don't use array.sort. Use merge sort methodology. So there's a time constraint there, I think. If I was in an interview, I suppose I'd ask the question, what kind of time constraint or what the time complexity expectation would be. Yeah, out of curiosity, Bill, I saw there was a question in here about what the time complexity of the algorithm was. Did you have any thoughts on that?
I haven't had a chance to look at that yet. So
Okay.
yeah, it's up on line 78 up above there.
Yeah.
So yeah, I haven't had a chance to think through it.
Yeah. Okay. Well, I suppose merge sort is faster than normal sort because you're not having to reiterate through the entire array every time,
Right.
or something along those lines. So, um, edge cases, I can't think of many. Maybe empty. What if we maybe get an empty array? How to handle duplicate numbers. Okay, so if I'm going to take the example that's given up here, where the array is broken down into various subsets, and the way that I imagine doing this is I would take every sort of pair of arrays.
So Ronnie, let me ask you a couple questions about your inputs and outputs. Is the array that you're returning, is it the original array sorted, or is it a sorted array that is a different array?
That's a great question, and I didn't address that. I assumed in what I did below that it was a new array, a new sorted array versus modifying the input array.
So why would you make that choice?
I didn't thoughtfully make it, to be honest. I guess it wasn't. Was it specified in the? I don't think it was specified in the instructions. Sorts an array of. Well, I suppose I could have made the opposite choice if I was thoughtful about it. The instructions maybe would lead you to sorting the actual input array, but in any case, that's not
why do you think you would choose one over the other?
Well, I think you would. I think it depends on the use case for the function, but you may just save yourself from a space. There's a space saving, I suppose, if you know you're going to need ultimately an array to be sorted. You save some space by sorting the input array and returning it by sorting the input array rather than returning a brand new array. If the use case is ultimately to just work with a sorted array after running the function. Does that make sense to you?
Yeah, it does. Okay, so let's assume that your output is going to be a new sorted array like you have. That sounds good. Let's go ahead.
So, this is weird to whiteboard without being able to draw it out. The way that I'm thinking about this is I need to be able to compare these two arrays, each adjacent array to one another, and populate a new array based on a comparison of their values. So I would compare 4 and 7. The lower number is 4, so I would push 4 into this new array, and then 7 is all that I'm left with. So I would get this. On the next two, I would compare 4 and 3. Based on the same process, I would populate another array that's going to give me 3. Oops. It's going to give me 3 and 4. And this is where I got a little bit, to me, the thinking through a merge sort and how it's better got a little bit tricky for me. But now I've got, just using these 4 numbers as an example, I've got 4 and 7. Got an array of 4 and 7 and 3 and 4. I know now that both of these arrays are both of these subsets or arrays are sorted. So when I compare them to one another, I can compare the first values. The lowest of the 2 first values is 3. I can then remove 3 from the first position in the rightmost array, move it to this new array. Then I compare just the leftmost position of each of the 2, which now is 4 and 4. They're the same. I do the same after removing one of the 4s, and now I'm only left with 7. I don't know if that made sense, Bill, but that's sort of the merge process as I understand it.
Okay. So is there a reason you've dropped off a couple of your array values from your example?
Just to speed this up. In fact, I'll probably just do this for the sake of this example.
Okay.
So how does that look in pseudocode? This is taking way too long, I feel like.
Yeah, you're doing fine.
You're all right?
Mm-hmm.
How much time do we have?
We have about 20 more minutes, so you're fine.
I'm going to go real fast. I'm going to try to go real fast through this. I want to make sure you have time too. So if I pseudocode this out, first thing I need to do is break array into an array of arrays with a length. Each one has a length of 1. Then I need to do work while this array has a length greater than 1. So as long as this array contains multiple subarrays, then I got to keep doing stuff. And then I need to traverse this array, checking every other array against its neighbor, against its adjacent array. And in doing that, compare first value of each of array versus first value of adjacent. array push lower of the two values to the new array. So I'm going to compare the values at index 0 of the two arrays that I'm comparing. I'm going to take the lowest one. I'm going to move it into a new array, and I need to actually also remove this value from its current position within the current array. And then I keep doing that comparison. I think I needed to do it here while either array while current array or adjacent array contains at least one value, then I do these things. So I keep doing these until I've removed every value from both the current array that I'm checking and its adjacent array, and pushed it into the appropriate position in some temporary array. When I get done with all of that, I need to push this result to another array. This was literally how I implemented this problem. I don't know if it's the cleanest way in the world, but I push it to that to something. I push this to sort of this results array that I'm ultimately checking here for a length of greater than 1. And then ultimately, once all of this is done, I think I might have skipped some step. When I break out of this while loop, I can return the result. I think I skipped something there, Bill, but anyway, I'm going to stop there because I'm taking too much time. And also, I guess I kind of did this example here, yeah. So maybe I'll quickly follow this through this logic. Yeah. So I've broken the array down into 4 subarrays. Now I'm going to traverse these 4 subarrays, starting with the first one. So initially, I'm comparing 4 to 7. 4 will get pushed into a new array. Okay. Get removed from here, 103. Then the only thing that is left in that comparison, so then it'll loop back because there is still a value remaining in the adjacent array. The only value remaining in either of the arrays is 7, so it will push then 7 to that new array. That'll complete, that'll get us to here. So then that will include an array containing 4 and 7. This gets pushed to a new array that I didn't initialize anywhere in the pseudocode, but it gets pushed to a new array. And the while loop, or no, the next iteration on this traversing of the array occurs, which will be I plus 2, so it's going to move from index of 0 to index of 3 because I'm traversing every other value. And then the same thing that just happened for 4 and 7 will occur for 4 and 3. That will complete. I'll have an array that has a length of 2. So this while loop will continue. The same process that just occurred will occur again to do further sort of those 2 values, and then results will get returned.
Excellent.
It feels like a mess, Bill.
No, you're good. That's good.
I feel like that was a tricky one to try to. Well, any of these toy problems I find are tricky to try to talk through. But
yeah,
I'm gonna stop sharing my screen. Sorry, I wait.
No, that's good. Let me just provide a little bit of feedback real quick.
Great.
And first of all, I know you're not right now in the same environment you would be in an interview, but make sure that you're front lit when you're in your interview and not backlit, because your face is dark right now.
Yeah, sure.
Your framing's good, and you do a good job of speaking to the camera and the interviewer, so that was very good. In the question I asked about the why you would want to do an array versus a new array, one of the reasons is we typically don't want to mutate the original array unless it's specifically called for.
Yeah.
So that would be something to remember as far as that answer. And I think almost every function that we deal with typically returns another array unless it specifically says like sorted in place, you know. So, but no, that was really good. I thought you did well. So,
thanks, Bill. I appreciate that.
You did a good job of talking and the whole time and asking questions of the interviewer when you needed guidance. So I thought that was good.
Oh, thanks, Bill.
All right, let's do this one from yesterday if I can.
Cool.
Okay, so let me get this big. So for the sake of time, I'm going to cheat a little bit. I wrote yesterday my inputs and outputs, but I'll go through them real quick.
Nice.
First of all, let me summarize the problem. The problem is that we're given a string and we're writing a function that finds the longest run of identical characters in that string and then returns an array with a tuple. The first value in the tuple is the starting index of the longest run. The second index is the ending index of the longest run. If there are ties in length, we're going to return the first one, and if it's an empty string, we'll just return null. So my inputs, we have a string of any length. It could be any characters, no restrictions there. An output is going to be an array with the start and end indices of the longest run of identical characters. So there's no real conditions. They could be any characters. My edges, I've got it that an empty string returns null. No runs of identical characters or runs of the same length return the first occurrence of the runs. So in this one, if there's no with ABCD, if there's no runs of characters, I'm going to get 0, 0 as my return. And likewise, if I have AA and BB and those have similar lengths for the runs, I'm going to get 0 and 1. Okay. And then you can see the other examples up here. So how does that look as far as the explanation of the problem and my inputs, outputs, and edges? Is there anything I'm missing or any other conditions I need to work with?
No, I think you got it, Bill.
Okay. So the approach that I'm going to take is, I'm going to try to iterate through the string. I'm going to kind of make note of when a current character is different than the previous character. I'm going to keep track of the current longest run of characters start and end indices, and then I'm going to start with an initial value and compare the length of the current run of characters being tested to the length of the longest run and update the longest run start and end. So I've actually done the pseudocode down here. So for the sake of time, I'm going to just jump down to the pseudocode that I did. And if we want, I can take this out because I don't believe I've completely finished the pseudocode on this. So Yeah, let's do this pseudocode again real quick. So I'm gonna initialize, or I'm gonna create variables for, let's say, to keep track of the longest start index and the longest end index, and these will ultimately be what I'll return. So as an example, I would have, you know, maybe 2, 3 as an output for the return. So I also have to keep track of my current. So I'm going to do the same thing for, I'm going to create variables and keep track of my current start index and current index in end index. So what I'm going to be doing is I'm going to be comparing the current. I'm going to start. I'm sorry. I'll loop through the string, and actually I'm not going to loop through the string. I'm going to use a while loop. So while the current character is not the same as the previous character, then I'll do some stuff below it that'll look. But this implies that I need to start at the second character in the string. No. Sorry, I'm thinking on my feet here. we're gonna start at 0, and we'll say this current character is not the same as the no, let's do it this way. Well, but this implies that we'll start at the second character in the string and do our comparison from there. So, well, that's the case. So if our current character is not the same as the previous character, it means our current run is done. And then,
hey Bill, when you say we'll start at the second character, you're saying we'll start what?
We'll start comparing with an index of 1 at the string at index 1 and compare it to index sub 0. So, or string sub 1.
So are you saying you'd have a for loop there and then a while loop inside the for loop?
No, I'm just saying that this while loop, so maybe it would be better to put this just here. I don't even know if I need to say that in my pseudocode, do I? It's kind of implied by the pseudocode. I'm getting into too much depth, aren't I?
No, I'm with you. This is good.
Okay. So I think I'd be okay just saying this, because actually implementing this would be in code. But the idea is that if I have to compare it to the previous character, I'm going to start, you know, at the second character to be able to compare it to the first.
Yep.
So I'm just going to leave that in the pseudocode. So if our current character is not the same as the previous character, we're going to end our current run. And if it is, So let's see. If not, or if it is the same, then we're going to increment our our current ending index. Okay, and then we're going to set our longest indexes to be our current ones. And that way, when we do hit this condition up here where they're not the same, we'll already have the longest indexes set, and we won't have to worry about setting those again. And we also need to do a check at some point to make sure that we just don't keep going. And so we're also going to have to check I guess we've gone through the entire string. And then, so at this point, if we can, at this point, we would kick out and we would return our longest indexes as a tuple here. Does this seem reasonable?
Yeah, I think so. I guess if so, this is why I was asking about the for loop earlier. So it says while the current character is not the same as the previous character. So what allows you to continue looking through the string once the current character is the same as the previous character? Is that if statement? Do you know what I mean? Like you're going to break out of the while statement as soon as the current character matches the previous character.
Yeah, you're right. So you're right. I would need to, so I would need to iterate through the string. And then I would also update the value that I'm looking at based on the results below. So let me explain this because I don't think I have time to code it out or to talk it out. But so like if I'm iterating through the string, I don't necessarily want to go through each thing. I want to start at a value, and then you know, comparing there. I want to keep, well, I guess what I'm saying is usually we would iterate through a string with like a variable I, and we would go a single step at a time. But no, I still need to do that, don't I? I still need to iterate through. Okay. So yeah, I thought I would have to update the value, but I just need to iterate through the string and compare each character to the previous one.
I see what you're saying though, because you could, in theory, you could increment I in the while loop.
Yeah.
And if you increment I in the while loop, then you got to pass it back to, you obviously don't want to iterate over stuff that you've already looked through in the while loop.
Yeah, that was my initial thought in doing this, is that I would just compare each character, do the increment in the while loop, and that way. But you're right. I would just basically you know, kind of update that index of any sort of for loop I don't know, it got into a weird thing. I'm not sure how to do this.
I think it's pretty. I think it could work though, because what you effectively. Sorry, I'm like, oh, I'm jumping in here, but it's an interesting way to solve it because you end up using the iteration, like the outer iteration, to iterate through each quote unquote run.
Mm-hmm.
And you use the while loop to track the size of the run. And so if you've got a run of 4 characters, then
right.
you sort of get through that, you capture those 4 characters in the while loop, and then when you get back up to the outer loop, you start at the end of that run.
Right. So you basically would add your current I to the length of the run to get your new starting value, and you could do that here. Instead of just saying I plus plus, you would say like I plus your current length.
Yep.
Right. So that's kind of how I was looking at it. So that's why I put here in my code, I will be modifying in the loop to, I will be modified in the loop. So I was kind of indicating I would still needed to do that here.
Yep.
I'm not sure if we have time to go through this. I guess maybe just a real quick string. Do we have time at all? Like,
yeah, go ahead. I mean, I think we have open time now, right, to watch videos on our own time and hack. So go ahead.
Okay. So let's say that we've got A, B, C, C. Now let's go A, B, B, C, like that. So we're going to iterate through the string. We're going to say so we're going to start at A. We're going to say is A not equal to, boy, what is that? Not equal to B. And in this case, that's the case. So we are going to go on to the next one. By the way, we initialize our longest runs with the first character. Mm-hmm. So our longest start is 0, our longest end is 0. I'm getting rid of this length here and just use subtraction to calculate that. So those are the values I'm keeping. So in this case, we're going to start with longest. As I said, longest is 0. I'll call it ls equals 0, le equals 0. So a is not equal to b, so we go on. And then, is b equal to b? Yes, we go into the string, so we set our, both our current start's still 0, but we're going to set our current end to the index of b. And we're also going to set our longest end. No. Yeah. We're going to set our longest. At some point, we're going to set our current values. So anytime we're successful, we're going to just keep track of that by setting our longest values to current values. So on the next one, we're looking at the second B and we're comparing to C, and that's not equal to, I guess I should indicate that, so longest start is equal to, oh. So if this is the case, I would have the current start is gonna go up 1, right? All right, and And the current end is also going to go.
Yeah, makes sense.
Start. And then here I would just increment the current end. Okay. So in this case, the current start is 1. The current end is 2. And then we set these longest values. And then in the next step, B is not equal to C. And so we don't have to do anything when we've hit the end of the string as well. So we're going to kick out, and at this point we have our longest value set to our current values. So our longest start is equal to 1, and our longest end is equal to 2, and that's what we would return. So I think that works.
Yeah, makes sense to me.
Okay. All right.
Well done.
What feedback can you give me?
I mean, I don't have anything specific, to be honest. I thought you did a really good job articulating your thoughts to the point where, I mean, maybe I shouldn't have jumped in, but like I was understanding what you were trying to do well enough to be able to sort of, feedback back to you, and so that was good. So yeah, nothing major, Bill. I thought it was good.
Well, thank you. I think the hardest part of this for me is going to be balancing the verbalization with the actual thinking about the problem.
Yeah,
and trying to solve it. Hopefully it comes to me as I'm going, but I've had a chance to look at this problem before, as you had as well. So where it's going to be interesting if we get like a brand new problem, and we have to actually think more about the solution, and how. I think that for me, that's going to be one of the biggest thing is how do I make sure that they understand, hey, I'm thinking about this. So
yeah, for sure.
Okay.
I feel the same way. Did you do much preparation along these lines just for like your entrance into Hack Reactor?
I did. So I did all my beginning prep on my own in 2 weeks. I decided like 2 weeks before the last cutoff date for the technical assessment was, technical interview. So there were a lot of the prep problems that we went through initially